What is going on, you guys, and welcome back to the channel. In this video, we're going to be looking at decorators, what they are, how to create them, and also how to utilize them. However, before we do that, we have to cover a couple of things. The first one being high order functions. Now, high order function is something that exists in both the realm of mathematics and computer science. And a high order function has to do at least one of the following things. It has to take in one or more functions as an argument or return a function as a result. Let's go ahead and create some examples. So we'll create a function called add3. It'll take in a number and then it will just return a number plus 3. Let's create another one, say add underscore 10, and then take in a number and just return a number plus 10. Okay, so these are two very standard functions. Let's go ahead and create our high order function. So we'll say addition. This will take in a function, so add func, and it will take in a number. Now underneath this, we'll say add func. As this is a function, we'll be calling it, and we'll pass in a number like so. So how is addition a high order function? Well, first of all, it takes in a function as an argument, and you'll see that in a second, and also then returns a function as a result. And just remember, it doesn't have to do both of those things. It can do at least one of them in order for it to qualify as a high order function. Let's go ahead and make use of it. So we'll say print addition, and we'll pass in add underscore 3, and we'll give it a number. Let's actually say 11. And let's just copy that. And in this case, we'll say add 10, and we'll pass in 11 as well. Let's go ahead and run this. And we get back 14 and 21. And just to kind of reiterate what we've just done, addition, it takes in a function, in this case add 3 on line 17, and also a number, so we just pass in 11. But one thing that you may have noticed is that we're not calling add 3 or add 10 inside it. We're not doing something like this. That's because this function is going to be called within that, so we don't want to call it just yet, as it will just pass in the return value. But we want to just throw in a function, and in order to throw a function into another function, you just call it like so, or you just write it like so without calling the function itself. Now, that's pretty much what a high order function is. This is a basic example of it, but it fits the criteria. But now let's look at what inner functions are. Now, inner functions is just a fancy term for nested functions or functions defined in functions, or if you want to call it function inception or funcception. But let's go ahead and create our own example of it. So I'm going to go ahead and create something like division. This will take in a dividend and a divisor. We'll create a function that actually does the division. So we'll say do division, and we'll just return dividend divided by divisor. However, we also have a case where divisor could actually be 0. So we can say, oh crap, 0. And we'll just return a string which says, oh crap, 0. And then just below it, we'll say if divisor equals 0, then return, oh crap, 0, not calling it, of course. And then return, oh, do division, like so, without calling it. Okay, so this is an inner function so do division is an inner function along with oh crap 0, because they're both defined inside of another function. They're nested inside of it. We're also not passing in dividend and divisor into any of these functions either. That's because both of these arguments are scoped to both of them, as they're both defined inside our division function. Let's go ahead and use it. We can do something like this. So we'll say print division, and then we'll say 40 and 8, and then we'll print division, and we'll say 13 and 0. Let me just comment these two out. And let's go ahead and run this. Okay, so what do we get? We actually don't get any like useful output. All we're getting is our functions do division and oh crap 0. That's because this division is returning our do division function inner function, and this one, because we're passing in 0 as a divisor, is returning our oh crap 0. But it's not giving us any like useful mathematical output. To do that, we have to put the brackets after that. We have to call the function that's being returned and then run it, and we get our output. Now, another way we could do this, we could say func1 equals division, and then 40 and 8, and then func_2 equals division, and then 13 and 0. And then inside our print, we could just remove this and say func_1 and call that along with func2. So we can say func_2. And then if we run this, we get the same output. But you can see it's starting to become a bit tedious. You know, we've defined our division function along with the inner functions inside it. So do division and oh crap 0. Then we call the division function. We've assigned it to func1, and then we call it the function that comes out of division. Or you can do this whole thing, which again is, you know, is just as confusing, because it's like, why are we calling a function with, why are there two brackets? You know, like it's not nice to look at. And we'll kind of like fix this or mitigate this when we arrive at decorators. But that's what inner functions are, and just before that, that's what high order functions do as well. So we've covered those two areas. Now let's start slowly moving into the world of decorators. So I'm just going to comment these two things out. And let's go ahead and create a simple decorator. We'll just call this simple decorator. And this will take in a function. So this is going to be a high order function, as it takes a function as an argument. We'll define another function inside it, so wrapper. So this is also an inner function. And we'll just say, I am calling your function. And we'll just call function like so. So whatever function we end up passing in here. And then we'll say, I just called it. And then finally, we need to return that wrapper. Okay. Now let's go ahead and create a function to use with this simple decorator. So we'll say something dumb. And this will just print rabbits eat dog food. So yeah, I'm assuming rabbits don't eat dog food. I mean, there may be some variation of a rabbit that does, but let's go ahead and utilize this. So we'll say simple decorator. We'll pass in, say, something dumb. And then in order to actually use it, we have to call it. So if I run this now, we get back, you know, I'm calling a function, rabbits eat dog food. I just called it. So we get, it's calling this and this and then this. But again, you know, we're not doing anything new here. We've just created a function which takes another function as an argument and then calling that function that is returned. Even saying that sounds confusing, and looking at it, it looks a bit weird. But this is where the syntactic sugar of Python decorators come into play. So let's create another function. So I'm just going to comment this out. I'm going to say something smart. And we'll just say print subscribe to Rhythmic. Okay, now we could go about doing this whole thing again. However, an easier way and a nicer way is just by saying at and then our simple decorator like that. And there we go. Now we can just say something smart. And then run this. And there we go. I'm calling your function, subscribe to Rhythmic. I just called it. So that's a lot better than doing this whole thing here. And this is what a decorator is. A decorator is this @ symbol along with the name of the decorator above a function. You can also use it on classes as well. However, that's beyond the scope of, we're not going to cover this in this video. But yeah, it's just a lot more cleaner. We're just calling a function. And what a wrapper or what a decorator actually just does is it wraps a function and modifies its behavior. In our case, like, it's not really modifying anything. It's just calling another function inside another function. But let's go ahead and go back to our division function that we defined earlier, and let's apply decorators to this. So I'm going to go ahead and create a function. I'm just going to comment this one out, and it's going to be called validate division. It's going to take in a function. Now our division function is also going to take in arguments. So let me just say pass for now, but what we're going to have is just say, or the function that we're going to decorate is going to be division, is going to take in a dividend and a divisor, and it's just going to return dividend divided by divisor. However, in our case, like we defined earlier, which is this in our inner functions example, we also want to handle when a divisor is 0. And we can do that with our validate division. However, in this case, our division function that we're going to wrap like this has 2 arguments. It has dividend and divisor. Now, how do we handle that? So inside our validate division, we can just say wrapper, and you can call this anything you want. It doesn't have to be wrapper, but it's usually you usually see it as wrapper. And this will take in asterisk args and asterisk quargs. And if this is unfamiliar to you, in the last video we covered args and quargs. So yeah, feel free to go ahead and check that out. However, to finish this wrapper, we'll say dividend and divisor equals args. We don't really care about quargs in this case. That's just there for completion. But now we can say if divisor equals 0, then we'll just say can't divide by 0 dummy. And then otherwise we'll just return the function that we pass in. So function, and we pass in args and quargs. And then finally we just return a wrapper. Okay, so that's how we handle that's how we decorate functions that have arguments themselves. So our division with dividend and divisor. Let's go ahead and try it out. We'll say print and then division. We'll say 40 and 8. I think that's what we had before. And we'll also do one with 0. So we'll say 30 and 0. Let's go ahead and run this. And we get 5 for our first call and can't divide by 0 dummy for our second. So yeah, that's how you handle arguments on a function that's being wrapped. However, let's actually go ahead and see what division, the name of this function object, actually gives us. Because we're wrapping it with validate division, we should still expect this to be called division. So let's go and see. So I'm going to go ahead and comment this out. I'm going to go and print division dot underscore name. So the name of this function. Let's go ahead and run it. And we actually get back wrapper. We should actually expect something like, something like division, right? Like that would make more sense because that's the name of it. We could apply it to other ones, like, I don't know, like if we ran it on this division here, it would be called division. But why is it that we're getting back wrapper? So with Python, as we're calling this division inside of this wrapper in a function that we defined in our validate division decorator, Python just thinks it's called wrapper. Now this can lead to some errors. I think when it comes to debugging and all that, like it can be a bit confusing and a bit misleading. However, to kind of like mitigate this, we can actually wrap this wrapper with another decorator, and this decorator comes with the Python standard library. Now for us to use it, we have to import it from func tools. So we'll say from func tools, import wraps. And I find this kind of funny as, you know, in where actually, given that we're talking about decorators, we actually use another decorator that comes with Python. But we can say above our wrapper in a function that we define in validate division, we can say wraps and then pass in the function here. Now, if we run this, we get back division. So now that's correct. Now division has the name division. Cool. So let's go back and look at this wraps decorator that we decorated our wrapper with. And I'm sorry if the naming becomes a bit confusing. If you want, just definitely like go back and just rewind bits of this. But our wraps decorator also, it actually takes in an argument itself. Like the decorator itself is taking in an argument. So how can we create a decorator that takes in an argument itself? Now this is where it gets a bit weird. It takes a bit of getting used to. However, yeah, let's just go ahead and write it. So I'm going to go ahead and create a decorator, call this repeat. And all this function is going to do is whatever function we wrap with this is going to repeat it a number of times. So we'll say amount, so the number of times we're going to repeat it. And then inside that, we're going to say decorator. And this is going to take in a function. Inside that, we're going to create another function called wrapper. This will take in args and quargs, just in case, you know, our function that we're wrapping has any functions. So it's always good to have this there. And then for I in range, and then amount, we'll say function and asterisk args and asterisk quargs. And finally, let's go ahead and first return wrapper and then return decorator. So we're kind of going a layer further than what we had before with our other decorators, which is validate division, where we have just one inner function. In the case where you want to add arguments or have arguments inside of your decorator, you have to go a layer deeper. So we've created an inner function, and then inside that function, we've created another function. And that's how you handle arguments inside of a decorator. So now let's go ahead and create a function, call this say something. This will take in amount. Sorry, not amount. So this will just print out I am being repeated. And then above that, we can say repeat. And we'll say amount equals, we'll say 10. Now if I go ahead and call say something, run it, we get back I'm being repeated, and this is coming out as 10 times. I'm not going to count it, but that's how you can handle decorators that take in arguments. But that's really it. That kind of wraps up our decorators tutorial. I hope you took some value out of this. It can be a bit confusing at first, especially with the more like for example, our repeat decorator that we created, where we have like an inner function within an inner function and all that. But definitely go ahead and mess around with this. Try come up with your own examples. It's the best way to learn concepts like this. However, like you will also come across a lot of decorators throughout your Python journey, especially when you use libraries like Django or Flask or Fast API, where they make heavy use of decorators when it comes to like, I don't know, defining endpoints for your APIs or whatever. But yeah, like you will see a lot of it. I mean, we even used one from the standard library, which is wraps. In a future video, we'll be looking at data classes that too will be making use of decorators. But yeah, if you enjoyed this video, please give this a subscribe and also a like. And I have a Discord channel, which the link will be in the description below. This code as well will be made available to you in a Replit link, which I'll also put in the description. But otherwise, stay healthy, stay safe, and I hope to see you in the next video.